Okay, in this section, we are now going to talk about how do we integrate exponential functions. Okay, so for exponential functions, let's do a bit of recap on differentiation first. Okay, because differentiation and integration, they are the reverse of each other. Okay, so recall when we differentiate exponential functions, okay, e to the power of x, right? We will get back the same function, okay, which is e to the power of x. Okay, and then when we integrate e to the power of ax plus b, okay, we write back the same function, e to the power of ax plus b, then multiplied by the differential of the power ax plus b. Okay, so when I differentiate ax plus b, I get a, so I multiply e to the power of ax plus b to a. Okay, so that is for differentiation, right? Okay, integration is the reverse, okay, somewhat the reverse. So when I integrate ex, e to the power of x, I will get back e to the power of x. Okay, because integration is the reverse of differentiation. Okay, so when I integrate e to the power of x, okay, I will get back ex plus c. Okay, so that's for integration. We need to add a plus c at the back. Okay, then how about if we integrate e to the power of ax plus b? Okay, so same thing, we will get back e to the power of ax plus b, but now instead of multiplying by the differentiated of the power, now I'm going to divide by the differentiated of the power. Okay? Okay, so while this one is multiply by differentiated of power. Okay, so that's the difference between integration and differentiation of your exponential functions. And then always remember, for integration, no matter what kind of functions you have, polynomial functions, your exponential functions, or even your trigo functions, right? Everything needs, don't have your so-called quotient rule or your product rule. There's no such thing as quotient rule or product rule in integration. That only applies for differentiation. Okay, so keep this in mind. Okay, so now let's do a few examples. Okay, so when we want to solve the following, okay, integration of e to the power of 3x plus 1 over e to the power of 2x. Okay, now don't look at this as the quotient rule. No such thing in integration. Okay, so the best way to do this when I have a quotient like this, right, it is to split it up into each of the individual terms. Okay, so I will split up this fraction. Okay, because there is no quotient rule. Okay, so there's no way I can do quotient rule for integration. So I have to split this up into each of the individual terms and then integrate them term by term. Okay, so remember your law of indices when you do this kind of exponential functions with powers. Okay, so therefore, when I split this up, I will have e to the power of 3x over e to the power of 2x plus 1 over e to the power of 2x. Okay, so when I integrate this, okay, let's simplify first. Okay, so for the first one, e to the power of 3x divided by e to the power of 2x. When I divide in this is of the same base, I will minus the powers, right? Okay, so essentially it means this becomes e to the power of 3x minus 2x. So e to the power of x. Okay, then when I have 1 over e to the power of 2x, okay, this is essentially my negative powers, so that I will have 1 over something. Okay, so recall in indices where I have a to the power of negative 1, then it becomes 1 over a, right? Okay, so a to the power of negative of anything, it becomes 1 over a to the power of n. Okay, so same logic here. If I have 1 over e to the power of 2x, then this becomes plus e to the power of negative 2x. Okay, so now that I've expressed in indices form here already, right? In each of their individual terms, I can integrate term by term now. Okay, so when I integrate e to the power of x, I will get back e to the power of x. Okay, then when I integrate e to the power of negative 2x, Okay, so first of all, I will get back e to the power of negative 2x. Then don't forget to differentiate by the power. Don't forget to divide by the differentiator of the power. So divide by negative 2. Okay, then don't forget your plus c here as well. Okay, so when I simplify this, I will have e to the power of x minus 1 over 2e to the power of 2x. Okay, so now I bring down this negative power. Okay, remember indices. Okay, when I want to remove negative power, I will bring it down. Okay, then I will have a plus c. Okay, so that will be my answer. Okay, so in this case, you need to be very familiar with all your indices laws. Okay, so that is for this case where there's no quotient rule, okay, in integration. Then now, for this, how about this? Now I have two exponential functions multiplied to each other. Okay, same thing, there's no such thing as quotient rule. No such thing as product rule. Okay, no product rule in integration. Okay, but what do we know? When I multiply exponential functions, right? Basically, they have the same base e, right? So when I multiply indices of the same base, I can add up the powers together. So this is how I'm going to simplify this. So recall when multiplying indices of same base. Okay, so in this case, it's base e. We add up the powers. Okay, so it means if I have a to the power of p times a to the power of q, okay, then this is basically just a to the power of p plus q. Okay, so same thing here. If I have e to the power of half x minus 1 times e to the power of 2x plus 3. Same base e, I'm going to add up the powers. So now I will have just one single exponential function. Okay, so when I integrate this, I will have e to the power of half x minus 1 plus 2x plus 3. Okay, so this will simplify to e to the power of 5 over 2x plus 2. Okay, so when I integrate this, same thing, I'm going to get back the same exponential function first. So e to the power of 5 over 2x plus 2. Then I need to divide by the differentiator of the power, which is 5 over 2. Okay, then plus c. Okay, so when I simplify this, right, okay, remember I will just put this on top and then this stays at the bottom. Okay, so this equals to 2e to the power of 5 over 2x plus 2 over 5 plus c. Okay, or you can also write it as 2 over 5 e to the power of 5 over 2x plus 2 plus c. Okay, so make sure they are in the individual terms added or minus up, then you can integrate them. Okay, so when you have exponential functions multiplied to each other, simply just add up the powers to get one single exponential function. Okay, then when you have quotient, okay, quotient of exponential functions, split them up into their individual terms first. Okay, then you integrate term by term. Okay, so that is for integration of exponential functions.